Okay, we're running. I can't tell you how long it's been running. I don't think 30 seconds. And we have some smoke, and it's pretty good smoke. I'm going to be watching my temperatures, and I'm going to be changing things as I go. Make sure I don't overheat. We're feeding 5.5 volts into the heater coil and about 3.5 volts into the fan, but the fan is getting pulse width modulated as well. Now it's been, I think, less than 2 minutes and we're up at 95 degrees. So I'm going to have to shut this off for a second, let it cool down. It's all brand new, so I don't want to get too ahead of myself here, okay? So there's 100 degrees C on the lid. That usually means it's hotter down below. And with a temperature like that, the thermistor down below is around 655. And that's, and I can't tell you what that temperature is, but it's hot. It's probably 140, something like that. What you're seeing is a new design, a different orientation, let's say, of the smoke body. You're familiar with how A.C. Gilbert did it, right? This is his smoke body, and a piston and all that. Okay, and we've been going along for quite some time with our smoke. And this is the one I started with a long time ago with the individual hot box for the heater and everything, and that sort of went by the wayside. And I went to a wider chamber and then a lid, and then everything else was crammed in there, and it was okay, but it was hard to get to, and it also had some airflow issues. So we started making some changes to it. One of the things we did was we widened the box and made it a separate box and did all kinds of stuff, and we had some success with that. This was the absolute first one that did something, and it was pretty exciting. So I went to a second version of it, tidied some things up, made some changes. But lately, I was looking at this, and I just was unhappy with how it went together and how wide it became and all that. So the change that I made was in the orientation of the smoke heater. So if this is the smoke body, then what I did was, the heater is normally sitting like my finger is. What I did was I rotated it so the heater is now in line. And there were some smokes from early on that had that, and then later he changed it. But now he didn't have a fan; he had the piston drive. So as you know, the fan pushes air through the smoke system and up the stack. And what I'm able to do by taking this guy and running him lengthwise, I'm able to lower him below the airflow, and I'm able to use the space underneath it to bring in the angel hair. Here's the reservoir of the angel hair, and here's the hair piled under the heater, and this is oil soaked, right? So the heater gets hot, the oil evaporates, it goes up, the fan is on, and it sends the smoke out. And it's working very, very well. The challenge I'm running into is the airflow and the heat of the system are not quite tuned up yet. Now, we have a lot of capability with our system. Well, I was going to measure this to see how long it took to make smoke. Let me reset my watch here. Okay. What a stupid thing. I'm sorry. I can't tell anything. It took no time. I have a stopwatch on my watch. I can't run it with my other hand. My other hand's GIMP. It just left, you know. Okay, so we see the smoke. Nice plume. This is, yeah, that's the full speed and the long duration. And what I can do, and that's at the higher rate of travel. So I can slow this down, like we're just pulling out of the station. We got a load. It's a hard pull. Oh, look, I got a leak. See the lid leaking? Crumb. All right, poof, chuff, 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 chuff. Now, that would be a lot faster. We don't have this. This is a demo system. It's not a real live. Everything's the way it should be. But we're close. I wonder where the leak is. Oh, I see it. Okay. So the puffing sequence, cycle, start, and all that stuff is all done right there inside where that red light is. That's a microcontroller unit. He is told the timing, the speed, and then he has rules that he has to follow. If we're going real slow, you do this. If we're going real fast, you do this. And he will adjust that. And right now, this is set for this test, not operating. So we have to make those adjustments. This little piece down here, right, you barely, if I put my finger on it, you couldn't see it, is the motor controller. And he is given a pulse, and then he sends out that pulse of energy to the motor and to the heater. And that's how we regulate speed and temperature by, instead of the light switch on all the time, we're flashing it. So you get to see a little bit and then it's out again. But I know it sounds crazy, but for these guys, it works. And it's what keeps them from overheating and gives them the energy they need to make what we want, speed and heat and whatnot. So that whole thing needs a calibration kind of a thing. But this is new, so I just want to say, answer the question, is it even going to work? Will it make smoke? Well, you saw it was making smoke. Now the question is, can we control it, and will it? I thought I saw smoke coming out, but I don't think it's my imagination. Can we control it, and will it overheat? And yes, we can, and it won't. And then next is, it's easy to assemble. There's only one part that goes on, and that's the lid. The lid holds the heat shield for the heater. The heater is soldered to the lid, so the lid is inside the heat shield. The temperature sensor is also inside the heat shield, and they're both soldered to the lid. So 4 screws, you take the lid off, you got the thermistor and the heater and a short piece of angel hair that's under the heater. It comes out. The bulk of the angel hair and the reservoir for the oil is in the nose. And then everything else is air channels and fan. This hole is an inlet, comes back to the fan puts it forward and it comes out the stack. And all along the top here, there's a big cavity. I'll show you 3D next time. You know, cross section and all that. It's pretty cool. But I think if you get this out of the way, and if you can look at this, you can see it's pretty narrow. I know it fits in the, it'll fit in the, Casey Jones. I've tested it already. It'll fit all the way. It'll fit right to the stack, which is great. So I'm going to put this in my Casey Jones, which is over here. Get it back together. There it is. When it's fully running and ready, I'll put the smoke in, and then we'll have smoke. And the Casey Jones, you know, the motor has been modified to run pull cars. There's another version of the Casey Jones chassis. With this chassis, where we have a different engine, here's called an E6. It's a little different look than Casey Jones. And then there's another one somewhere I have its chassis, but then we have what we call the Mini Royal Blue. This is a body. It has its own chassis somewhere else, and it will have this also, and smoke and everything. So I'm working on these engines, and I hit a stumbling block with the dang smoke, and I really had to get it right. And now I'm feeling extremely comfortable with how it is working. how to zero this thing. I had a stupid watch. Okay, it's smoking. How long it took, but it's smoking. It's back to smoke, and let me get my little temperature gauge up here so I could. That probe just rests on a solder joint that is hooked up to the smoke, to the heater. Yeah, that's right. Yeah, it's on the heater. So we're at 70 degrees centigrade. It's already hot. Look at the smoke. Isn't that beautiful? And so you're going down, you're seeing the smoke, chuffing, sounds, lights, all that. It's going to be great. And the relationship to speed will all be done in that little microcontroller. So there it is. This is generation 3. I think it's great. It's making good smoke, very good smoke. It's a new design. It's a new theory. It's a new layout. It's thinner. It'll fit more engines. And I'm going to make a stationary version. Yes. And engine version. And the engine version will probably just be like a one size fits all thing. It's thin. It's not that long. And it will usually, I think it'll fit. I don't know if it'll fit the Franklin. That's pretty small. But it'll fit everything else. It'll fit the Atlantic and all those others. Okay. And the engines that we build on our chassis with our frame adapters, I'll make sure it fits on that too. Okay. So we're way high. I got to come down now. So there you go. That's where we're at. And it's been fun. And I think I'm going to close it out. I'm going to go have my turn to cook tonight. Isn't that nice? We share. I'm taken care of, believe me, I am. So I don't mind. My turn is fine. It's fine. So I got to go. I got to wash up and get ready and start cooking dinner. Okay. Joy, thanks.